Alright, so let's continue with our stack lang. So last time we looked a bit into how to write assembly code for our data structure, and more specifically for pushing or the data structure constructor and getters for fields, right? So yeah, and we also have this dupe keyword and swap, but these are gonna be added in the compiler itself. So we just looked into how to implement pops and allocate memory. We also try to figure out how the memory layout should look like, and I guess the plan for today. So yeah, I guess let's nix and then fuzz, right? So running this thing, basically we try to simulate this program, like how this program would look like. I guess it's only this part. So we try to manually translate this code into assembly, and now the point would be to do it automatically with a C program. But yeah, that's the goal for today. But I guess first we can start with something a bit simpler. So if you remember from last time, we were building here the AST, right? So the AST, one sec. I guess here we are building the AST, but just for a data structure, because that's the only thing we know how to parse right now. So if we actually run main on our example, you can see that it lists all the tokens, and it also parses this data structure, right, into an AST actually. So I'd say first we can try to start with the AST for functions. That's gonna be hopefully not that difficult. And then we can maybe just try to start on the assembly, because that's gonna take a while. So yeah, right. So here I'd say just to force ourselves to do that, maybe, I mean, we already know that in example we have a data and then a function. So let's actually call to stack parser parse func, and then we parse the parser here and then a func, right? We don't have the function or the func. So let's define stack ast func, right? But again, we don't have this data structure yet, so we have to define it. Let's go to data. So how are we gonna do that? We are gonna copy paste this thing here, and let's call it func, right? And how does a function look like? It has the func keyword, nothing special. Then it has a name, then a list of types, the return types, which is also like a list, and then the body. So let's do the name, which is gonna be a string slice. I really like that. Then a dynamic array of args, which I think it's also gonna be a string slice, because it's just the types. We don't have names for them. Yeah, I don't think it would be useful anyway to have names for, like, this is more of a comment actually right now, because I don't really know how are we gonna do type checking, but we'll see. So we have a list of args and a list of returns, right? Like our types. So what we expect on the stack and what we put on the stack. And then it's gonna be another list. Weirdly enough, it's like a list of tokens. So I mean, is it gonna be just string slice for each one? I think I don't think so. Like we might want another kind of data structure here to indicate these guys. Actually, we can check inside of cool, but I don't really remember. So in this other one, right, in the include, in parser, here I defined the data structure for, I called it node info because I wanted to also have the line and column. So that could be the data structure that we actually want to have. And then, for example, we have all of these expressions, and then we have a bigger expression, which can be any of these. So maybe it makes sense to have an expression node, I guess. All right, so because here we can also have integers. That's a thing. So the body should be a list, obviously, but it should be a list of something. A list of something. But we'll figure out what this something is, right? I guess. We could also take a look at, I mean, I use node info for almost everything, so I think that's a good idea to keep in mind, because maybe we don't want to use the string slice directly. Maybe we want to have a node info that's gonna store more stuff than just the string literal that it represents. But for example, I was curious to see like a class node. Yeah, class node. So class node has yeah, maybe it makes sense to use node info, right? So right now it works to keep it as a string slice, but the thing is that maybe in the future we'll have error, some error messages, right? And for the error message to be useful, you need a line and a column. So maybe that's what we want to store in here, the line and the column, or I guess the pause. So might as well store the token, you know, like, but yeah. So let's see again. So node info, that's interesting. And for example, if we have expression int, right? Expression int, how does it look like? It's still a node info. So here, even at this step, yeah, makes sense to keep everything as a char pointer. Okay, so, but then even here would make sense to store this as node info. Yeah, so let's do that actually, right, for the beginning. So let's go to our first part. So stack lexer, it's not here, it's the stack parser. So we have these two functions. And then what if instead of string slice, we make a typedef struct stack AST node. So this is like the basic node, right? And I'm just thinking, should we unsigned int position, or should we already convert it to line and column? Like for position to work, we need the lexer, right? Because lexer post to LC. I don't have the function yet. I guess let's keep it as pos, and the idea is that when we print the error, we convert it to line and column. Like, it's not worth to convert it to line and column before we actually need it, so let's do it like this. All right, so then we should replace all of these with something like this then. So stack AST node, right? So even here is going to be stack AST node, and then we do so here is the value and then position. So let's do value, it's dot value, and then dot pose is equal to token dot pose. And you might say, okay, but it's kind of just the token, right? And yeah, I mean, you're right, it's kind of just the token. All right, so here it's the same thing, but besides, it only contains the value and the position, so we don't care about the kind anymore. Like, the kind is already known, right? It's gonna be a name. So I guess that's the other point. Okay, so here stack AST node again, and this should be a stack AST data field. And see, like, here comes the problem with void pointer in C. If you change this, you don't really know where the errors are, but it's fine, right? It's still completely fine. So stack AST node, change that, and here we need to build the actual position token dot value, token dot position. Yeah, so that's how we do that, and these guys are already taken care of because this function is already fixed. Okay, so let's continue. Oh, that's basically all. Okay, there's also, yeah, so printing needs to be fixed. I have to say dot value, right? Dot value. But now I would expect that if I do make and then run this, it should still work, right? And the cool thing is that now we also have the position in the code of that stuff. So yeah, so again, this thing should now be a stack AST node for the name. These things should be stack AST node, and here we'll see what the body is actually, because right now we don't know. But let's start with parsing a function. Let's go ahead and take this thing because it's gonna be kind of similar, but it's gonna be parse func, right? And this thing is gonna be a func. All right, so first of all, we need to initialize our func structure. So let's do args. Here we have stack AST node. Then we also initialize our reds, and we have to remember to initialize the body, but for now it's to do. We need to initialize the body, and again the body is gonna be also a list, I would say. Could be a separate data structure, and then, but I mean, in the end it's a list. Okay, so first, what do we expect? a func keyword parser. These are panics, but again, I think I'll do error handling on my own at some point because it's not that fun, and we already did it for cool compiler, but again, it's been like a really long time since then, so I don't know. Anyways, let's do trying to find a name. So function name is gonna be this guy. Perfect. Then we read something, and now it's gonna be interesting. We expect, what if we have a function that doesn't return anything or doesn't do anything here? That's interesting. Because see how main is defined? Maybe I need parentheses just to be able to parse that thing like this. Maybe I need a parenthesis in the function. So it's gonna make things easier. But even then, like, let's say you have a function that just returns something. So for example, main is a function that always returns something actually. So do you have to also add the arrow? I think so. I think the arrow should be mandatory, but then it's gonna be weird, like a function that doesn't return anything or takes anything as input is gonna be like that. Yeah, now this is a bit cooked. Feels like you kind of need this arrow because you want to separate these things. Because let's say we ignore the error in some cases. If you have int, is it the input or the output, right? If you have the arrow, now it's the output, and now it's the input, right? We could also say that if you don't have an arrow, this is always the output, but then you need the arrow. I mean, it sucks either way, so this is how you would write that it returns int. I mean, it looks kind of ugly in my opinion, because you cannot really say just int, like it returns int, but then because you do yeah, I think the arrow is needed. Parentheses probably not, but maybe it's gonna look better with parentheses. Yeah, I really I hate I hate the arrow. Maybe it's like the args should be in parentheses, right? And the outputs not, or maybe even the outputs must be in their own parentheses, like this. And we can even have commas in between them or something, and then it makes more sense for this one to exist, right? And now you can see it pretty obvious that it takes nothing and it returns an int. So maybe that's how we want this thing to look like. We want parentheses, so it's gonna be exactly parsed like this stuff. So it's gonna be also OCD friendly, right? Like this thing looks like this thing, and this thing looks like this thing. So let's do it like this, because it makes it more obvious how the thing looks like, and it's a bit more pretty. Like, I mean, it's still ugly, but it's better than what it was before. Okay, fair enough. So we expect an opening parenthesis, right? Then here we have two cases. Maybe we can do like a function for parsing the list, so we can just reuse it. So it's gonna be this thing basically, and we can have something like static int stack parser parse func nodes, let's say. So stack parser is gonna be the parser, and then stack ds dynamic array pointer nodes, right? So we need these things for return result. So we can just call something like, so let's remove all of this, and then I mean, for now I'm just gonna do stack parser parse func nodes parser, and here we need to pass the address of func arrow args, and then I would say it's gonna be the same for rets, but here we also need to do arrow, so let's do the arrow in between them. So parser read arrow. I mean, if you don't even need the arrow though, you can just do this. Like, arrow is not even a needed keyword. I mean, what do you guys think? Do you want the arrow or not? We can make a poll on that. But I mean, the arrow is useless, I guess, right? So we can just parse the list of nodes here and the list of nodes here. Sure, we should do some error checks, but let's see. So if we find, oh, one sec, I need to add this thing as well into the function. So it's gonna be like this. It's gonna do, what the fuck? Okay, so it's gonna be you parse func, then you parse a name, and then you parse these groups of things. So in here we expect an opening parenthesis, but we found something else. Okay, then if we find the rparen, we just stop. It means we found like it's empty. It's not important. All right, so then we have here a stack AST node, because I said these are gonna be stack AST nodes. Oh, but that's even that doesn't work. I was thinking maybe we can make it somehow that you can also send, but yeah, wouldn't really work. So stack AST parser parse. Oh, what? We don't even need to parse anything. We just need to check 1 sec. So yeah, we just need to read it. We just need to read it and expect it to be a name, right? Something like this. That feels like it could be a function though. Let me just see. So token is equal to this. Then we say expected a name but found something else, obviously. Find whatever, and then here we need to append. We kind of need to append this thing, right? Stack AST. Now, did I define it? Yeah, stack AST. So, yeah, basically, wait, node is not even used. Yeah, okay, fine, fair enough. So we read the token. Like this thing could be a function though, if you think about it. And it somehow, I don't know, yeah, we'll see. And we append this thing, right? And then we read another token. If it's closing parentheses, we break. If it's a single comma, we continue. And then we say that we expected something like that. Okay, so that's how we parse the arguments. Then we need the in keyword. So let's say that we read another one, and here we have token in, expected in but found something else. Then we need all the stuff from the inside, and at the end we have end. Question is, it can be any number of tokens, so you can even have an empty function, I guess, if you are really into that shit. But who knows? Yeah, so here then I would make another function, stack parser parse func body, and then func body. We don't have this function yet. Yeah, so let's see. Here I said it's gonna be an AST node, but I think it's actually gonna be stack AST. So like if you think about it in readme, we have either functions or variables or something like that. So node is gonna be part of that. Okay, so it's exactly like expression here, but right now our expressions are just integers and identifiers, right? Those are our only expressions. So I could just say stack node expression. Feels weird, but why not? And this should be like a list of expressions. So let's do that. Stack AST expression, and let's see. Type struct stack AST expression. We need stack. Just want to see how I named it. Expression kind. So stack AST expression kind. It's kind, and then we'll need a union. So let's type def enum this thing, the stack expression kind, and probably we'll need, yeah, to add all of these expressions. So, but for now, as I said, we only have identifiers and integers, so it's not that. Okay, so my convention is capital letters. Perfect. Let's just go here and let's see, stack token. So stack AST maybe expression, and then we have int, and we have identifier, right? Should be kind of, or like name. Maybe name is a better, like number. Okay, fair enough. I'll just use it. All right. So we have the kind, and then for this stuff, we'll have stack AST node integer and name. So those are going to be our options, right, as nodes. I mean, right now I called it numbers, so maybe just have it as a number, but we'll see if we try to refactor it. Okay, anyways, so in here we have stack parser body. We need to define this one. It's just going to be a list, stack parser func body, and here we need to give it also the dynamic array of expressions, expers, stack AST expression. So that's the type of our items. All right. Like this one shouldn't be as difficult because it's gonna be just a while loop. So let's do something like peak. Something like peak, and then while token kind is equal to stack token or I guess while token kind I kind of have to say that it's well, I could also just do something like while true, and then let's have a switch, for example, switch on token kind, right? And we have a few cases. Case token, or I guess stack token name, stack token number, and default, right? And I would say that default should be return 0, and if we get the name we have to read it, right? We have to read that thing, and if we have something like a node, I think we should. So we already know it's a name. Expers. Can I say token is equal to? Again, but it's kind of useless because we already have it. And then we break. And here we just need to say stack AST expression, and then we have dot kind is equal to stack AST expression name, and then name is actually equal to dot value is equal to token dot value, and position is equal to token dot position. That should do it. I guess I can also just cast this thing. Damn, it's okay. I can also just cast it. Right, so that's actually how it should look like. And here, for example, is gonna be a number, and this should be a number, but the rest of it is the same. So right, something like this. Like here we append a name and here we append a number. All right. And in case, so if we find the token name, we read. If we find the token number, we read. If we find anything else, we just stop. Right, and the token is not consumed. So here, when we do parser read, we expect to find an end. Right, and we read it. Yeah, right now, you know, panic, but in the future I'm gonna try to do proper error handling. So I think that's all for this part. So if I uncomment this one, it should actually try to parse that function. So we can try. So if we run this thing, we should still see, oh shit, it's a while loop somewhere. Okay, let's do a ds panic just for the memes. Percentage s func name dot value. I mean, it's not the right type, but whoa, what? Oh, it's a string slice .str. I mean, it's, you know, it's not gonna work, but oh shit, what? Oh, that's crazy. Anyway, let's do char pointer value is equal to null. Yes, string slice to owned. The string slice should be func name value, and this should be value. Oh, I need the address. Okay, weird. I haven't compiled it though. Ivec dot, right? So we find the function name, that's perfect. What if we try to print it here? Does it still work? Still works. So we also parse those guys, even here. Do we parse correctly the in? Man, I really like to printf debug, it's the best way to do it. Oh, we also parse that. Who would have guessed? But I would assume that we don't parse this thing. Yeah. And I wonder why. So, oh, ew, ew, bruh, ew. I think we have to do it like this actually. I forgot to update the token, right? So I had to do peek inside of the while loop. Okay. So let's go here at the end and let's try to print actually the function. So in here I'm gonna do func name value. Let's go to and show all the args. So stack AST stack AST node. This is an argument. Func args, and I'm kind of butchering the. Alright, so here we get arg into name. I guess it's arg.value and that's it. I mean, it's a type, but who cares? Okay, let's see if we get the right types, right? It should be ivec2, ivec2. Nice. And now let's also print the returns. So let's count. We have a ret. We put it into here. We take the ret value and we also print the returns. So it should be an integer at the end. Nice. And let's print now the body. The body is gonna be a bit more interesting, I guess. So I'm gonna do body. Here we have instead an stack AST expression. It's an expression. So we have the expression, and now we have to do an if statement, or I guess it's a switch on expression kind. It's a switch on expression kind, and if we have a number, we need to say expression number dot value, and if we have this one, we need to say expression name, and then we print it. Right? I mean, sure, fair enough. I could also do name and number, and that would tell us if it's a name or a number. So if we look here, I mean, we have all of them as names, but if we go into example and just break it a little bit, we add two numbers there and just run it, it's gonna be numbers. So we actually parse. We are actually parsing the language, kind of, because you know, we hard coded these things. So right now we have parse data and parse function. What else do we need is a stack parser parse, which is going to take the parser, and maybe we'll call this program. Or maybe it's going to be parse AST and it's going to be AST. I mean, program sounds program. program, right? So I'm gonna do stack AST prog. Actually I'm gonna call it prog, because I'm pretty sure someone will be annoyed, like, why did you call it prog? Exactly, that's why. Okay, so let's actually delete these. I'm gonna comment out all of this stuff because we won't use it anymore. I'm gonna do a special dump for a program. So let's actually go ahead and add this data structure. So right now, what's a program, I guess? Right, that's the current question. Well, a program is a list of either, well, it's a list of data and functions, so we can just do it like that. Stack AST, I was thinking to make it a single list, but you are right, it should be data and functions. Fair enough. So it's prog. We have a list for data and a list for functions. Fine, I'll do it the plural. It's, I think, datum, but it's not the same. I mean, it's structures. So datas. Datas is how, I mean, it's my language. Come on, don't backseat. Just kidding. Talking to an existing chat, but okay. So prog. All right. So how is this thing gonna work? We need a token. Right? We need to pick the parser, and we have two options. We either find function or we find data. So let's do equals. Let's do it like this. Let's do an else if and then else. Expected data or func. And found whatever. All right. So what happens if we find data and what happens if we find something else? Okay. But then again, it's like a list, so we'll have a for. Okay, let's remove all of this stuff. We don't need it. So there's also the case where we find stack token end of file or end of file, let's say. Expected data func or end of file, but found whatever. So if it's end of file, we just break, and you're gonna say, oh, but what do we break? The while true loop, obviously. The while true loop that you didn't even know it existed, but now you know. All right, so I guess stack token can be defined here. Let me just backtrack for a second, and also because here you can see that stack token can be defined there. Anyway, that was a segue, but let's get back to this one. So we pick the parser, right? We find data, we find function, then we find end of file and we close. If we find anything else, well, you suck at coding and we are gonna tell you that you suck, right? But it's in a nicer way, but it means that you suck, hopefully. I mean, I'm pretty sure I'm gonna see this error a lot, so we are gonna laugh then, I guess. Stack token data. So how are we gonna do this stuff? Well, stack token data, no, it's stack AST data is gonna be equal to 0, obviously, and we are gonna call to stack parser parse data. So parser, and we give it a pointer to data. So this thing should, in theory, parse a data structure. So then, oh, and yeah, just not to forget, we need to initialize the program here, because otherwise we are gonna be hooked. So data's funcs stack ast func stack ast data. Yeah, that's right, that's freaking right. So that's that, and oh, mimic array append. Oh yeah, that's how we do it. Okay, prog datas, and we give it the address to data. Perfect, that's way too easy. So let's have func. Here I need to parse func, and here I need to append a function in our funcs list. Okay, that's cool. So it means that now we can actually parse a program. We don't need this guy. I don't think we need a token. So that's gonna parse a program. Oh shit. I'm doing, yeah, I'm printing the tokens here. So I guess I'm gonna do, so stack lexer next. I'm gonna do a function with stack lexer dump. Maybe file pointer stout or something like that. So like, where do you, but it doesn't even matter because I'm using dslog. Okay, so it doesn't really matter, because dslog, you can just define your own stds if you want. Yeah, I don't know why I laughed at that, but it's always funny. Stack lexer dump. All right, and here we can just say that. So now we have a function for dumping the lexer, so we can just say stack lexer dump lexer, and this thing should write the tokens. Perfect. So if we want to see the tokens, we call stack lexer dump, but I want to do stack parser dump. Let's see where that comes. So stack parser dump, void stack parser parser dump, stack parser is gonna be also pointer, why not? Just like that. I'm also gonna have a void stack parser 3, stack parser. It doesn't do anything because even stack lexer 3. Oh, I mean, it kind of makes sense to do something weird like that, but what does it has these fields. So I'm gonna do parser lexer is equal to 0. Well, stack lexer 3 parser lexer, right? Then we do talk is equal to 0. I mean init, right? Init should have some useful stuff. Yeah, like this. Why not? Oh my god, stack parser 3, okay. Like that. So I guess, yeah, let's do the dump. So we have a parser. Well, I guess we need to parse a program if we want to dump it. Yeah, it makes more sense that this function is on the AST prog, so maybe stack AST prog dump, like stack AST dump, and it gets the prog or something. Where is stack? Oh, it was fine. Okay. I just want to move this thing a bit. Like, where is the stack parser? Yeah, I don't know. Yeah, whatever. Let's see. So we have stack parser parse prog, and then we have stack ast dump, and it gets a program. So how are we gonna dump the ast though? So we have to do a for loop. Unsigned int I guess doesn't even matter. Yeah, sure, fair enough. Can be like this. We go into prog dot datas dot count, and I mean I deleted, but I think I pushed changes. Stack length C, because I have I deleted the dump, right? So that was actually useful. So I need something like this. And how are we gonna get the data? Well, easy enough. We have data, and then we just say ds dynamic array get prog datas index I data. Right, and here is gonna be dot value, obviously. Dot value. Away. Dot value. Okay. So I guess I can do stack st dump prog, and we should in fact see our data structure. Now I'm not sure if I want it to be done with dslog. I guess fprintf and maybe having even the file pointer ast out makes more sense. And here we can just send std out. Right. Oh, it's a bit fucked. So I would maybe just add 2 spaces here or something like that. And yeah, don't forget the new line. Yeah, maybe something like that. Or we could even... Oh, but I forgot how you say that. Let's see, printf, pad spaces. I always forget this thing, left pad, but yeah, with this thing. So you have to say something like, oh, but wait. What if I want a variable? Yeah, like this. This is actually what I wanted. So fprintf, and then you have how much, for example, 2 spaces, name type, and now std out. Right, that's what I want. And yeah, maybe this can be another parameter or something, but for now I'm just gonna keep it like maybe const int indent is equal to 2. Right, so now if we run this thing, yeah, we get the data. We could even say data space and maybe have a new line in between all of these things. Data ivec2, and then it's fields, right? All right, so now let's do the functions. So for function, I already have some stuff. I guess all of this should come first. AST func, we'll have func, funcs, func. We get the name, we show the function, then we need to ident this thing. We get the arguments. Let's do something like let's actually do something like this maybe. Oops. Arg percentage %d. Oh, but for this stuff we need j. And I think we need to do j and type is extra. So it's like argument 1, 2, 3, and so on. All right. So that's how we do that. Then we have the returns. Maybe we should do the same thing, but here it's gonna be red. And then we have the body of the function. Right, and I guess for the body, it's gonna be something like this. And it's just gonna be a list of I guess it's S, yeah, and not without that. And without these. Okay, so let's see. I guess it kind of works. It's a bit maybe this like this shouldn't be on the same yeah, I think I know what I want to do. I want to do another printf here and be like, wow, be like body. Right, and then here have ident times 2 or something. Alright, so like this makes more sense then. So yeah, we parse the entire program, right? And we have data structures, we have functions, all of this, and we also have the main function. Yeah. I mean, this took quite longer than I expected, to be honest, but let me just do stack parser free. Can we run both? Yeah, we can do both. That's nice. And what would happen if I run valgrind? Shit, still the realloc stuff. Okay. Oh, but that's because we don't free the. So we have this dump function print, but we don't have a free for the thingy. So we could do free stack AST free. And data, stack AST data, I think. Yeah, wow. Maybe each one needs its own free. Right, so let's go to the first data structure. So stack parser has its own free, it's fine, but maybe we need something like void stack AST node free. Right, and then have stack AST node. This thing, I don't think it should do anything. I mean, we have the string slice free. But it doesn't do anything, right? If I remember correctly. Yeah, doesn't do anything. But it's still a good idea to call it, in my opinion. So here it's parse data field. I'm gonna do st data field 3. This one just has to call to stack st node free, field name, and field type. I think that's how you have to do it there. Then we have stack AST data, which needs a free function, stack AST data free. So this one is data, and data has a name and fields. So this one still works, but then we need to do a for unsigned int I is equal to 0, I is less than data fields dot count. We have to manually free each one, so I'm gonna get a reference then. Wait, what is fields? Fields is stack st data field, yeah, obviously. So here I think we need to get references to be able to free it. We cannot get a copy. So this dynamic array get, and we have get ref for that purpose. Data fields I, and we give it a pointer to field. Okay, this one needs to be a pointer as well. Right, and here we need to do void pointer pointer. Yeah. And then we can actually just free a stack st data field free, and we just free this field, right? And at the end, the important part is actually dynamic array free. This is actually what takes up memory. The rest of the things do not, but I think it's still a good practice to have free for everything. Okay, so this one takes up actual memory. Right, and let's see what's next. So next up is a function. Oh, it has more. And we also have expression. Yeah, I mean, it's fine. Let's do stack st func free. It's a bit weird. I would just move these ones up here, and then maybe have a function to parse an expression instead of using it inside of the body here. So let's say it's probably gonna be something like this. Huh. Not sure, because if you think about it, if you parse an expression, you might want to error. Wait, we actually want to error here, though, right? Not really. I mean, in this case, for this one, we don't want to error. But in general, we would want to error. But I mean, this is gonna be the only place for it, so it's not okay. Let's do then a free function for the expression. AST expression free, right? It's gonna be expression. So we need to check the kind. Which expert kind? Right. And if we have a number, we just want to AST node free the number, and otherwise we want to AST free the name, and obviously break after each one. I think that's it for the stack AST expression. All right. So what else? I mean, yeah, it would be nice to have this one as its own function, and somehow the body function checks that you have, but I mean, it is what it is. Even this one was yeah, I mean, whatever. So let's go to this free function free. So for function, obviously, yeah, we have name that we can free, and then we have args, reds, and body. So function args, it's AST node for an argument. Function args arg, and here we need to free AST node free, right? I think that's the idea here. Args are just AST nodes. Okay, so we can just copy paste, I guess, func args can be freed, and then we have reds, we get the returns, and we free that, and then we free the entire array, and then the last thing is the body. So here we have expression, st expression. Here we have expressions and stack st expression free expression. Okay, and then we do the body. Okay, so I think that's it for functions. And then we just need to free up the entire program. So stack ast prog free, right? Program. We don't have anything here. We have only datas prog. Stack ast prog prog. Oh, I made a mistake here. It's data. We get it by reference, and we stack ast data freed, and then we prog free the datas, right? And it should be the same thing for functions. So let's just replace all of these. We just say func it is going to be funcs func free, and yeah, funcs. Okay, so that should be how we free up the entire program. So here at the end we should say stack AST free, or I guess prog free prog. Only thing is I should define these at the beginning. Like before result, usually you'd put them, because if you do return defer, you won't have it defined. All right. I think that should catch all the cases. Let's see if it still works. I mean, obviously it still works. And if I run valgrind, we still have some things. We have some string slice to owns inside of stack dump. Stack AST dump. I guess we have string slice to owned for name, but we don't free the name. I guess ds free null name. Okay, fair enough. And also pipe. Right, we have to free because we allocate this here and we have to free it. Fair enough. So then here we allocate it, so we have to free it. Let's just do it like this, so it's easier to see. So these are all allocations. Okay, I'm also gonna put them at the beginning just to have them at the beginning, right? And yeah, so we allocate with free, we allocate here with free it, we allocate here, we need to free it. So let me just copy paste this one. Obviously allocate, we have to free. Maybe this is gonna be interesting, but we have to free as well here. Right, it's always gonna be allocated, so yeah. Stack AST free. Wait, what? I mean, I already have stack AST free. It's stack AST prog free. I mean, whatever. I guess I could rename it to that, but because we have stack AST dump and stack AST free, but it's the same thing. Right, and now we have everything was freed. Perfect. Who needs Rust when you can just use free? I mean, so yeah, now it's pretty decent. We are able to get the AST, get the tokens. I'd say that the next step is to generate some assembly. That would be nice. I mean, we were generating assembly at the beginning, but we downgraded to be able to do the AST first. I mean, I think I'm okay. I mean, most of these are fine. I just have to do better error handling in these. Yeah. So probably I'm gonna do that first. Yeah. Okay, so I mean, I don't really think I have time for starting the assembly part. I think that's gonna be it for today, but let me just see, like, no, it's not test, it's tested, awesome. Yeah, like actually generating all of these, I guess it's a better idea to just leave it for, starting it from the beginning. Maybe it's gonna be more fun. So yeah, let's do that, the assembly next time. So let's try now to maybe do better error handling. Right, so I said about this post to LC function. Post to LC, where it's defined here. Because it's a pretty good one, we can go to Lexer init because it's related to the Lexer. That's for sure. So we have Lexer post LC. We need a stack Lexer. We need a position, and then we are gonna output the line and the column like this. I think that's fair. So we have line column, Lexer arrow buffer, like this. Maybe we should also check. Let's do like int result is equal to 0. Then we have defer. So my question is here, what if you use a pos greater than buffer length, right? So that's what we need to take into account. So in the beginning maybe, or maybe even here, doesn't really matter. If pos is greater than Lexer buffer length, greater or equal, return defer 1. We don't really want to say it's an error though. We are just gonna say that, okay, get out. We cannot do that. But otherwise, if we are able to, then we check these things. And how this thing works is that if you encounter a new line in the buffer, you increase the line, otherwise you increase the column. So it's kind of cute little function. All right. So let's go into the parse program now. And let's think first about this one. Let's try to make the program fail during the parsing phase here. So how do we want to show errors? Well, first of all, Lexer pos to LC. We are gonna do parser Lexer. The position is token pos. right? It's the token position, and we need unsigned int pointer line 0 call 0. Oh, it's yeah. So if I was just thinking, this thing can fail, right? I guess that sucks, but yeah. I mean, it is what it is if it fails, right? We'll see. But here, if we look at the parser, because I really like the way I did error handling here. It's weird. What? Oh, I have this one. Parser show error. Error. Right. I have all of that with VA args and stuff. vprintf. Okay. And then I had defines for this error. So let's copy paste this error handling function, because it was a pretty cool, in my opinion, one. So let me just go to parser init, stack parser init, and let's paste it here. And I'm gonna call it maybe parser show error. And this one is gonna be a stack parser. And I'm pretty sure we need the format and VA args. Now, I was setting the like I had the error bit on the parser to indicate that it errored, but I don't know how to do that yet, so let's not. Right, I can take the current token, that's nice. Right, I can do stack token. I mean, I don't even have to because I have parser. Right, that's the current token. I could do file name, but I don't have it yet. Token kind. So stack token illegal. We can check if it's illegal. First, let's do const char pointer file name is equal to null, just to have it. I think it's gonna be interesting to do like file names and stuff like that, but okay, no, for now let's just do that. And let's maybe have a file pointer stdr, but I mean stdr is gonna be defined, so you can just define it, stdr. And I'm not sure, I think you have to print it like this. So we have lexical error if it's a token illegal, and then we need to do position lc. So int unsigned int line signed int call post to lc. So basically I need this thing Right, I need this stuff. So parser parser took position, and this gives us the line and the column. So then we can just show line and column, and I guess even better, we can just I mean, I could build the string with a string builder and return a string that contains the error, and then you can decide where to print it. But I'm not sure. So here, if you call this thing, it's printing an error. I mean, you can have the error in here. So right. I mean, you can do sprintf, but that's yeah, let's do string builder. And let's actually return a string, right? I mean, I don't know how that would be useful, so let's just leave it like this. So we just print the line and column here to standard error. Then if we have token illegal, then we know it's a lexical error, I guess. And I could just say illegal token %C. Not sure yet. Or it's what percentage? Anyway, we won't need line and column. I mean, let's just say illegal token for now. Oh yeah, because here we have if token has something, then we print it. If parser token value, but this value is a string slice. So we just check if its str is not null, I guess. And then we can just do char pointer value is equal to null. ds string slice to owned, and here we can put parser toc value and address to value, I guess. Come on. std error, and we can just display that value and then ds freed. Right, and then we put a new line. So yeah, would be like line and column, then whatever, then the illegal character, and then this thing. Right, I mean, in cool, I had lexical error, but you can have multiple lexical errors in cool. So maybe we'll do more than, right, here you can have like error type, multiple errors. But even in token type, you had like, oh, weird, I thought, yeah, you have illegal, okay. But yeah, in cool you have like illegal token and then multiple errors for what that can be. But for now, let's just skip that. All right, so then on the else case, what does it mean? So you called this function. Okay, I said that I don't have this one. So maybe I just want to show std error, syntax error, right? So we have a syntax error. We have a syntax error, so we do this stuff. Oh, std error. And then we have to, yeah, I did a printf, funny. I have to do this as well. So I think, yeah, you have either like a lexical error or a syntax error. So, yeah, like the idea is that in a lexical error, you may encounter an illegal token, and then you have to say, oh, let's say you had prepared the error. So when we panic, right? So when we panic, we can say, oh, we expected the name, but we found illegal. That's not really useful. So it would be useful to hard code parser show. Would be more useful to say, oh, we found an illegal token with this value instead of that, right? I think so. Let's just do stack parser show error. Right, and now when we ds panic, we could have stuff like here. We could have stuff like parser show expected, right? So we could have a function. Oh, stack parser show expected, right? And we have expected and what we got. Let me just see the first panic. So expected a name found. Stack token kind to string. Okay. Stack token kind to string. So I could just take this thing, and if I say stack parser show expected, I need to pass the parser and then what we expected. So stack, I guess, stack token name and token.kind. Right, this would be the way to do it actually. Let me just see in cool. Yeah, so I did that and then I used panic mode, but yeah, it's exactly the same thing. That's funny. Parser show expected, that's a good error, right? So then here is the same thing. We expected a name, but we got whatever. Let's find more panics. Expected data. Here it's expected name. Then it's expected L parent. This is here. It's two of them, so it's an OR. But I have that, right? I have that as well. I have a define for it. What I meant. So let's go here, and we can add it. Expected on, expected to, and got. So we can just replace it like that. Expected 1, expected 2, and got, right? Stack parser. Wait, what? Stack parser show expected to. The fuck? Yeah, that's weird. R parent or stack token, comma. Here it's expected only 1, and it's L parent expected. Oh, X it's expected, obviously. Okay, so here it was L parent. Here it's a name. And I think, oh, panic. Expected to, comma, stack token. Shit. So here it's expected only 1, and it's a stack func. Right here it's a name. Here it's in. And I think the last one is probably end. Oh, we have more. Oh, here it's 3 of them. So here it's like data, func, stack token, EOF. Stack parser row. And I can do also 3 of them pretty easily. Percentage S or yeah, it's funny. This one is something like fail to format, fail to create a string. So these are just not gonna happen. Okay, and now let's just say that we're going to example.sl, and let's forget this one. Let's see what happens if I expected, but see, it's kind of bad because it doesn't stop, right? But I have parser show error. I think I put, yeah. Let's make, right, it says expected parentheses got name, and then obviously expected data func or elf, and got name as well. That's just because it's gonna propagate the error on line 1 column 12, right? So yeah, but for example, what if you forget about the in? Right, expected in got name, and again it propagates the error. We want to not do that, and obviously like here we continue with parsing and everything because we don't really stop if we get an error. Like parsing should like it stops, right, if this thing is not equal to 0, return defer 1. Like it stops, but we still go forward with it. What the fuck? I fixed it. Right, so now it stops. Expecting in got name. But yeah, that I mean, it's on me to figure out how to do proper, like if you get an error, how do you make it not propagate, right? Like in cool, I added on the parser, where the fuck is the parser? Stack parser. I added stuff like, let's say, boolean failed, right? So we knew that it was failed. So if another error message that was somehow, like, just to not propagate the error messages, right? Because let's say we go here and we remove the in, and maybe we also remove this in. Right now I don't think we handled those cases. We only get the first error and then we stop, but I want to also find this error. So that's why we want to do some kind of recovery from errors. So for example, if you miss the in here, you search the end keyword or something like that, right? And when you find the keyword that lets you continue, you continue with parsing from that stage on. But I mean, parsing is already compromised, so that's just to be able to show all the errors. So I think, yeah, I mean, it's fine for now. Let's say it's fine. We are able to parse all of our structures. We still have to add if statements, but first let's do the assembly. So I think I'm gonna do that next time, but we already have an idea of how the assembly should look like. It's not that complicated, but we'll see. Hopefully I don't forget until then how we implemented all of this assembly. So yeah, I mean, thank you for sticking until the end. And yeah, now you can see that we have the AST and all the tokens. So next step is to do the assembly, and we won't do tree address code or an intermediate language because the language is already extremely simple. So the language is already like really simple. It can be translated to assembly quite easily. So that's the advantage of this one. We don't do intermediate representation. So yeah, that's I guess that's all for today, and we'll see in the next one.